Hi, and welcome to Calculus Examples. I'm Dr. Finch. Today we're going to look at a sequence. And remember, sequences are just lists of numbers. So this is a list. We're going to see if it converges, in other words, if it goes to a specific number, or if it diverges, which means it doesn't end up, that list just kind of moves around. It either goes off to positive infinity, negative infinity, or it might bump around a lot and never actually go to any particular place. So if it converges, we want to find the limit, and that's one of the things that we are going to be using. We use the tool of limits, and that is a very useful tool to have. So what we can do to figure out if our sequence converges is we can take our limit as n goes to infinity of 3 plus, we're going to put in the term of the nth term of our sequence. Now, as a reminder, we're thinking of this now as a function rather than as a sequence to take our limit. So it's a little technicality, but it's not that important. Now that we have it written as a limit, if you recall a long time ago when we talked about limits, and you're taking the limit of a polynomial divided by a polynomial, you look for the highest power on both the numerator and the denominator, and you pull that out. In this case, it's squared, n squared, so we're going to pull an n squared out of both the top and the bottom. When we pull an n squared out of the numerator, we get 3 divided by n squared plus 5. You can distribute that back in to double check and make sure that we did that correctly. When we pull an n squared out of the denominator, our first term is going to be 1 over n because we already have 1n there. And then when we pull out the n squared of our second term, we're left with a 1. Now that we have this, we can cancel the n squareds on the top and the bottom. And the reason why we do this is so that when we look at this as a function, anything that has the form y is equal to 1 over x or something similar is going to have this nice shape here where as x goes bigger, we go to 0. So that tells us a couple things. That tells us that 3 over n squared, because n squared is going to be similar to 1 over x, that goes to 0, and 1 over n as well goes to 0. And if you enjoy explanations like this, subscribe. I'll be doing Calc 2 problems all spring. So at this point, we have our limit as n, we've taken our limit, we've taken our limit. So we are left with 5 in the numerator, 1 in the denominator, which is a lovely little number 5 as our solution. Thank you for listening.